welcome to the Future Medicine Roundtable 2021. Over the next 90 minutes, we will be talking about the challenges we face in tackling the current pandemic, but most importantly, the pandemics of the future. This will be your debate. My name is Michaela Küfner, and I have the pleasure of hosting this today. We will be taking your questions when we talk about what lessons we should have already learned and still need to learn for those future pandemics that are certain to arrive. And to set the scene, we will first hear from Professor Dr. Christopher Baum. He's the chairman of the board of directors at the Berlin Institute of Health at the Charité here in Berlin. He's also the chief translational research officer of Charité. And with me also is your other host, Andreas Kastorf. He's the editor of Der Tagesspiegel, the most important daily broadsheet newspaper here in Berlin. But first of all, let's hear from Professor Baum setting the scene for us today.
Well, ladies and gentlemen, on behalf of the 600 employees of the Berlin Institute of Health and the close to 20,000 people working for Charité, University Hospital and Medical Center here in Berlin, it's my pleasure to welcome you to today's event. Are we prepared for the next pandemic? This is the topic, the key question that we would like to address. Well, unfortunately, the next pandemic appears to be the next wave of the current pandemic. Are we prepared? We should be, but here I have my first message. We really need to use the armamentarium that research has provided us with so rapidly within only a few months' time. We need to use our novel smart weapons against the pandemic with much more consequence. Let us consider the vaccines and the monoclonals, two of the highly successful deliverables of recent research, both achieved with unprecedented speed from discovery to routine use. However, it turns out that it is not enough to have them available. We need to constantly improve our logistic of delivery and our approach to promote the acceptance of these modalities in our society. Are we prepared for a yet unknown next pandemic? Much less so. For a yet unknown future pathogen, we may be able to make use of some measures that helped reducing the spread of the current pandemic. But the next pandemic may use another route of infection and involve a pathogen of even greater stability. Thus, our protection against the next pandemic needs to be an enforcement of basic research into host pathogen interactions. At the same time, we need to actively explore and learn from the successful paradigms encountered in the current management how to improve team science in academia and collaboration between academia and industry. Here in Berlin, we are seeing an enormous solidarity among everybody involved in the management of the crisis, and this is the greatest thing we can really use for our future, the spirit achieved in the management of the current crisis. And this spirit is coupled to delivering robust and reliable research data as a prerequisite to translate novel findings into real-world practice. So are we prepared? Better prepared, I would say, than 2 years ago, but certainly much more needs to be done to state that we would be well prepared. With that said, I thank everybody who contributes to our event, either by being here or by presenting work and ideas in movies or by following the event online. And of course, I also want to discuss everybody involved in the roundtable that we will have around us later on. Future Medicine is a collaborative format of the Berlin Institute of Health with Berlin's major newspaper, the Tagesspiegel, created to promote the exchange of knowledge in science and society. Thus, I would like to conclude by thanking the Tagesspiegel, here represented by its publisher Stefan Andreas Kastorf, and everybody contributing to the success of this conference.
Professor Baum, thank you very much for setting the scene for us there. And this pandemic put science at the crossroads with the media more than ever before. Mr. Stefan Andreas Kastorf is the publisher of Der Tagesspiegel here, and you and me, we have a lot of colleagues who had to learn fast, but also saw those nerdy colleagues with science degrees suddenly bloom as we were faced with very new challenges. So
Not me.
Mr. Kastorf, we look forward to what you have to say.
Thank you very much. Very pleasant good afternoon to all of you. Dear Professor Baum, thank you very much for your kind words. I would also like to warmly welcome you on behalf of the Tagesspiegel. Since 2016, we have maintained the tradition of co-hosting a Future Medicine Science Match with the Berlin Institute of Health at Charité. It's usually a live event where we meet each other face to face. This year, for the second time, we have to transfer it into a virtual gathering due to the circumstances we are going to talk about in a couple of minutes. I'm glad we came up with the round table idea, which is a more than adequate adaptation of the original format to the pandemic circumstances. Thank you all for being with us today. I'm sure that we will have a very interesting and enlightening round table. We are happy and honored to have so many renowned international speakers for today's event and are very excited to hear about their insights. I want to use this opportunity to thank the BIH. It's due to their outstanding scientific reputation and performance that we were and are able to organize this high-quality scientific conferences. The BIH's enormous efforts in preparing this event and their very friendly and cooperative interaction with us enabled us, even under these circumstances of a worldwide pandemic situation, to have an event with highly regarded speakers and participants from all over the world. Thank you, especially Professor Baum, Professor van Kalle, and Dr. Zeltman for your ongoing efforts to make this event an enriching and an inspiring event for all participants. It's an honor to work with you, an honor. Scientists in Germany and elsewhere have played an outstanding role in getting the pandemic under control. They prevented the worst in the first weeks and months of the pandemic by clarifying how to protect from the virus with short-term measures. And it were scientists who developed vaccines that opened the door to a more or less back to normal life. They are able to answer the question that is the focus of our event today. Are we prepared for the next pandemic? What are the learnings for science and politics? And what are the side effects of pandemic on the health system, like, for example, the delay of diagnosis and therapies of other diseases? Can we apply the lessons learned to other pandemics? This is why all of you participating scientists are so important, and we are glad and thankful to receive your insights. We are looking forward to listening to the Impulse lecture of Dr. May of Bristol Myers Squibb. We also would like to thank BMS for kindly supporting this event. After that, we have the opportunity to listen to a very interesting discussion round with Professor van Kalle from BIH, Professor van Messling from the Federal Ministry of Education and Research, and Professor Sander from Charité. And of course, we are happy to have with us Dr. Morgan from the World Health Organization Health Emergencies, who is going to share his thoughts with us during his closing keynote. Thank you all for being with us today. Before I close, let me share one thought with you about our role as Tagesspiegel. As Berlin's leading daily newspaper, nationwide recognized, we and other media are trusted senders providing important information, educate our readers, and classify scientific findings. An important learning during COVID-19 is how crucial clear communication to the public is to the public in defeating the pandemic. Newspaper's motto, rerum cognoscere causas, translates into finding out the causes of things, understand what happens. It originates from the works of Latin poet Virgil, and is over 2,000 years old. Sometimes I feel that it has never been more up to date than today. Thank you.
Mr. Kastorf, thank you very much, and we look forward to that debate later on. In fact, today we will have all the various disciplines that met at the crossroads of this pandemic. Communication also, of course, is currently playing a pivotal role in getting people convinced that it's worth considering getting vaccinated at the very least, but also where funding comes from. All of that we will debate later, but this is all about the scientists, and a lot of scientists entered videos giving us a behind-the-scenes look at their daily work and at the preparations that are currently underway as I'm standing right here to prepare for that potential next pandemic that might be looming. So first of all, let's take 3 minutes and listen to a bunch of PhD scientists who give us a look behind the scenes in how work has changed in all of those laboratories, not just here in Berlin, but also around the world.
The Bavarian Health and Food Safety Authority reported the first case of coronavirus infection in Germany today.
Hello, are you in the lab?
Hi, yes I am.
Could you please check for the expression of ACE2 in your dataset? This is the receptor of the SARS-CoV-2 virus.
Oh, it looks like they're actually expressed by specific airway and alveolar cell types.
That's interesting. This is potentially mechanistic.
The Robert Koch Institute reported 281 new cases of infections with SARS-CoV-2.
The number of cases is steadily rising. Current health safety measures such as mask wearing.
The WHO is currently working with a team of epidemiologists to investigate the origins of the virus. Hi, Professor. So I just had the introduction for the Biosafety 3-level laboratory today. Do we already know what kind of sample we would be using?
It would be nasal swabs. Do you think we can get cells from there?
Ooh, I don't know, but we'll just have to see, right?
Hello?
Hi! So from the data, we can actually see that critical cases of COVID-19 have more cell-to-cell interactions.
Very good. And it looks like immune cells have a strong inflammatory signature. This is very important. We should publish this.
Hello?
Hi, we are going to collaborate with cardiologists to investigate COVID-19 in patients who have hypertension. Would you be able to help?
Sure, but why are these patients interesting?
ACE2 is also important for regulating blood pressure, so drugs against hypertension could affect its expression and therefore also disease severity.
Hey, so it seems like patients treated against hypertension have no increased risk of getting COVID-19.
I agree, and according to the data, they should continue to take their prescribed drugs, since it might even reduce the risk of critical outcome.
Hey, I just talked to colleagues from the pediatric department and we were discussing why there are almost no COVID cases of children in the hospitals.
That's an interesting point. Will we collect nasal swabs from children?
Yes, and we might start soon.
Hey, the children dataset showed some interesting differences.
Yes, I looked into it. It seems like the children have a pre-activated immune system and might therefore be more efficient at clearing the virus.
Oh, could that explain the differences between children and adults?
Yes, indeed.
So just an insight there into how much expertise, but also donuts and coffee and communication went into action when news of that pandemic broke. It clearly was the moment and still is the moment of the intersection between scientific breakthrough and also a pharmaceutical industry that needs to be prepared. So we're very pleased to now get that view of the pharmaceutical industry. With us here is Michael May. He is here with us. He's the Vice President and Medical Director of Bristol Myers Squibb here in Germany. So we look forward to your keynote.
Thank you very much. So it's an honor and pleasure for me also, and also for Bristol Myers Squibb, to be a part of this fantastic event. Within the next 10 minutes, I will share some thoughts from the perspective of pharmaceutical industry with you. So firstly, I would like to address some key achievements of biomedical and biopharmaceutical research addressing the COVID-19 crisis so effectively with joint efforts. Secondly, I would like to draw your attention to some group of patients tend to be forgotten during the crisis. I'm speaking about patients with chronically ill severe diseases like cancer or cardiovascular disease. And thirdly, I would like to look into the future, looking what have we learned from the pandemic so far. So starting with my first key statement, overcoming the COVID-19 pandemic is a joint effort. Together with other key players, research-based biopharmaceutical companies are an important part of the solution, taking care of our task today and in future. The COVID-19 pandemic is also a challenging time leading to impressive success and records, and I would like to figure out three key aspects with regard to this. Never before so many highly effective vaccines and drugs have been developed and made available in such a short time. I would like to remind you that 4 months after the pandemic was officially declared, there was a first antiviral approved drug against COVID-19 in place already. The development of a first vaccine, either on mRNA basis or DNA, was completed in less or a little bit above 1 year. A rapid ramp up of production capacities was achieved even under pandemic conditions. And despite the temporary shortage of vaccines, there were no disrupted supply chains in pharma in general. And thirdly, a close cooperation and many collaborations between smaller and larger biopharma companies and key academic institutions were established. It was great to see how fast clinical studies were underway, enrolling thousands and thousands of patients worldwide. However, we also did observe that clinical trials in non-COVID related conditions were severely impacted and slowed down or even halted during the pandemic situation. Even though we are at Bristol Myers not specialized in vaccines or in virology, we also made our contributions here. We tested some of our medicines in various settings in clinical trials for COVID-19 patients, and we are currently looking in a phase 2 trial for an antibody cocktail potentially neutralizing SARS-CoV-2 in COVID-19 patients. Thus, to sum up, the innovation model of the biopharmaceutical research has proven its value during the pandemic, and the public awareness on medical research and the societal benefits have increased significantly. Looking forward to key statement number 2. Acknowledging the scientific achievements in making effective vaccines available quickly. We have also seen many silent victims of the pandemic, for example, seriously ill patients with cancer or cardiovascular diseases, for whom screening and medical treatments have been postponed during the lockdown. So in available data, we have already seen that many preventive examinations, screenings and treatments were severely limited or delayed even for patients with cancer and cardiovascular diseases, especially during the first wave of the pandemic. Reasons were multifaceted: fear of contracting the virus, contract restrictions being in place, and limited services in clinics and practices during the week-long lockdowns affected both the number of elective surgeries and appointments for screening or clarifying symptoms with a general practitioner or specialist, as well as emergency care in cardiovascular. There are a few data available. I would like to mention a few only. The Barmer Krankenkasse, for example, estimates that in Germany 2,600 cancers went undetected in the first wave of the pandemic last year alone. A DAK data analysis from 2019 and 2020 showed that in 2020, around 26% fewer skin cancer screenings were performed in German doctors' offices compared to 2019. As a logical consequence of this, a decrease in the number of newly diagnosed melanoma in the first half of 2020 by about 25% compared to the same period of the previous years. We saw 50% decrease in hospitalizations, also for outpatient sensitive conditions such as cardiovascular diseases. Fewer patients were hospitalized for new onset atrial fibrillations. And during the first lockdown, inpatient care for acute myocardial infarctions in Germany decreased by more than 30%. At the same time, besides affected patient care, the pandemic also had a severe impact and imposed challenges on clinical trial programs due to embedded patient recruitment, suspension or halting of treatments in trial programs, and access to trials. So I would like to reference here the mostly worldwide known database, the so-called RAVE database, where we have seen a decrease of 60% or also up to 75% of sponsored trials between the first and the second quarter of 2020. For many cancer patients in advanced stages of their disease, this potentially meant that their last resort of taking place in clinical trials and such receiving innovative new substances or combination therapies was gone. Looking at this from a broader overarching perspective, this increases the risk of delaying medical innovations, since this indirect effect of COVID-19 on potential morbidity need to be added to the direct effects of the pandemic and will sometimes only be clearly visible a few years later. Coming now to the third statement. Even if we might not know all the future answers and solutions to these questions already, enhancing digitization in patient care and research will continue to play a decisive role in ensuring that patient care and medical innovations are not put on hold, even under challenging conditions such as a pandemic. There are many aspects we need to address in research and in society. Firstly, not answers for all of these questions are available yet. What lessons can we learn from the experience of the current pandemic? What do we need to deal with available data in the future? What gaps have become evident in prevention and everyday treatment? What is in fact needed to make digital healthcare sustainable, fit for the future and a possible next pandemic? I believe that there are no ultimate answers to these questions yet, and there are certainly many more aspects to be discussed. But for a start, the following approaches are worth to be explored in my eyes for helping to improve the situation for people with severe chronic diseases like CV disorders and cancer. I think we have to enhance a systematic collection of comprehensive nationwide healthcare data to more accurately assess the impact of COVID-19 pandemic on healthcare and patient care. Secondly, we have to utilize and accelerate the current momentum for increasing general adoption of digital offerings and corresponding healthcare applications. From a patient perspective, we have increased the adoption of telehealth offerings, which were picked up speed during the pandemic. While there were only a few thousands of video consultations between doctors and patients in Germany in 2019, this has increased significantly to over 1 million in the second quarter of 2020 alone. From a research perspective, what we can do is to increase digital site monitoring. So we have started a project together with the University of Essen by just adding an element of a software program at a trial site that allowed the clinical monitors remote access to the files of the patients, including in the clinical trial. So at the end, I would like to say that medical progress is teamwork. We have to bring all different players in our society together to be prepared really for the next pandemic. Thank you very much for your attention. I hope some aspects and questions I have presented here will spark the further conversation, maybe especially in the panel discussion, and looking forward for a really entertainment event. Thank you very much.
Thank you very much, Dr. May from Bristol Myers Squibb, and certainly thank you for raising the whole issue of silent victims of this pandemic as well, which of course we will include in the debate that will follow here shortly. Also, what we of course want to do is look behind the scenes of that research that has been going on, not just here in Germany, but also internationally. So we have a second short clip of about 3 minutes, where scientists take us behind the scenes into their research about the immune response relating to COVID-19.
Hello, I'm Tommaso, and here at the Proteome Dynamics Lab at the MDC, we're studying the effect of SARS-CoV-2 on macrophages. Since these cells of the immune system act both as frontline soldiers fighting infections, but they're also a bit like generals, telling other cells what they should do. So we took macrophages from healthy donors, we infected them with SARS-CoV-2, and then we measured the abundance of 7,000 different proteins of macrophages to see how the virus was affecting and changing these cells. We found out that SARS-CoV-2 makes the macrophages go a bit crazy, so that the macrophages tell other cells to produce too much of that gooey stuff that is around the lungs, or fibrotic tissue. And this kind of lung fibrosis is what then causes severe respiratory problems in COVID patients. We hope that knowing this will help in coming up with better therapeutic options for COVID in the near future. Thanks for your attention, and bye!
Hi, I'm Sophia. I'm a PhD student in the group of Live Alexander at the Charité. Already at the beginning of the pandemic, it became pretty clear that COVID-19 is a disease with many different clinical manifestations, and that the immune responses to the SARS-CoV-2 infection plays a critical role in how the disease progresses. In collaboration with many other research groups, we performed our study to understand the innate immune responses to the SARS-CoV-2 infection at different disease severities. We therefore analyzed the myeloid immune cells, especially the monocytes and neutrophils, in patients with a mild and a severe disease course, and looked at different time points after symptom onset. We used single-cell transcriptomics and proteomics techniques in 2 independent cohorts and saw differences in the immune cell composition in these patients. In mild COVID-19 patients, we saw activated monocytes, which are basically ready to defend the patient against the virus. And in contrast to that, we saw in patients with severe COVID, monocytes and neutrophils that were dysfunctional, and saw a considerably higher number of neutrophils that were immature. And these cells contribute then to an immune response which is insufficient and ineffective in severe COVID-19 patients.
I'm David.
And I'm Pinkus.
And we've been working with COVID-19 vaccines in the team around Leif Sander and Florian Kurt here at the Charité Department of Infectious Diseases and Respiratory Medicine.
We all know that the elderly make up one of the largest groups at risk for severe COVID-19. However, they made up only a small fraction of participants in the vaccine trials. We investigated the immune response to COVID-19 vaccines in a cohort of elderly persons and compared them to younger healthcare workers. What we found was that the elderly not only exhibited significantly lower levels of SARS-CoV-2 specific antibodies and spike-reactive T cells, but that the response was also significantly delayed, and 1 in 10 elderly didn't produce reactive antibodies at all. Thus, a timely second vaccination for the elderly is necessary to elicit an adequate immune response to COVID-19 vaccines.
Additionally, when evidence of rare but severe adverse events in younger persons after the AstraZeneca vaccine came to light, the question came up whether they should receive their second vaccination with an mRNA vaccine, such as BioNTech or Moderna. we found that the so-called heterologous immunization was comparably well tolerated. And in addition, compared to the classical regimens, the heterologous immunization even showed better immunogenicity. Therefore, we concluded that a heterologous immunization might be a suitable vaccination strategy.
So, the new COVID-19 vaccines have been a game changer in this pandemic, and we're looking forward to continuing our research.
So bright and enthusiastic minds working here in Germany, but around the world on this very pandemic that we're experiencing now, but also laying the groundwork for what there might be to come. The question we will try and answer here today is whether that is enough. How well prepared are we for the next pandemic? Because I'm pretty sure it's not a yes or no question. And we have experts, I'm very pleased to say, from very different perspectives here with me today. First of all, Professor Christoph von Kalle, he's the head of the Clinical Study Center of the Berlin Institute of Health and at the Charité clinic here. He says, considering that the current pandemic did not threaten the majority of the working population, much worse things could have happened. If this was just the amuse girl from Hell's Kitchen, it will be rather important to figure out our scorecard in all honesty. And we will be talking about that scorecard at any moment now. And most importantly, of course, also virtually all of the studies conducted here in Germany went across your desk. So we will be talking about that. Then we have Professor Veronika von Messling. She's the Director General of Life Sciences at the Federal Ministry of Education and Research. When the pandemic struck, it was her job to decide where to put public money fast. The German government instantly spent around $1 billion in research towards vaccines and treatments. And she says at the onset of the COVID-19 pandemic, we benefited from an excellent research landscape and long-standing expertise. That's here in Germany. But we need to build strategic inter- and transdisciplinary global collaborations to improve equitable access for everyone. That, of course, still is a huge gaping gap. So we'll be talking about that in a moment. Thanks for being here. And we have with us Professor Leif Erik Sander. Just this week, he publicly shared the latest concern over the nearing fourth wave here in Germany. He was on stage with the German Health Minister Jens Spahn and Lothar Wieler, the head of the leading institute here in Germany, the Robert Koch Institute. Professor Sander there warned that the situation is critical and that there's no change of a trend in sight. He expects some 30 million people here in Germany alone will need booster shots and expects more pandemics in the future. So I will start with you, Professor Sander, and that very gloomy outlook that you gave this week. Are we already learning lessons for the future, or are we still in the middle of failing to learn a lesson about the current pandemic here right now?
Well, I guess we have to discriminate between the science part and the public health and sort of dealing with the pandemic, acute pandemic threat part. I do think that we have obviously learned important lessons both in the scientific arena as well as in the public health arena. And however, there is a discrepancy between the public awareness of the critical situation that we're facing right now, so the public awareness and the situation that we actually have in the clinics, on the wards and on the ICUs. Matter of the fact is that we have steeply increasing incidences, so more cases, but we're also seeing more hospitalizations, and we do have less capacities on our ICUs. So all that being said, in the background of the tremendous scientific progress that has been made with the development of highly effective, very, very safe vaccines available to everybody, at least in Germany. This is obviously hard to grasp, both for the public as well as for us healthcare providers and scientists. I think the public still has a lesson to learn, and that there is a solution to this, and that is vaccination. There are obviously some public health measures that could be improved. I think this is probably today we're talking about the scientific part. So I would just like to basically make the connection to the science part, where I think we have learned important lessons, and that is that we, through extensive collaborations as also outlined in the statement by Professor von Messling, between industry and academia across disciplines, we have made very fast progress. But we've also learned some harder lessons in that obviously some of the tools that we have at hand, both in funding as well as executing studies in Germany, might have to be tweaked a little bit in order to respond even faster to situations like a worldwide pandemic.
Professor von Messling, I would like to ask you, I mean, when you picked up the phone and you realized what was heading towards you. You're a virologist yourself, so that was kind of a lucky coincidence, I'd say, that you knew what everybody was talking about when scientists were warning you. What was the immediate thought that went through your head, and would you act the same again, knowing what you know now?
Actually, the short answer is yes, we would do the same again. And the question,
please hold the microphone. Yeah, okay, so yes, after you.
Yes. Yeah, when the whole pandemic started, and this is a research perspective, the first order of business, not just in Germany, but I think in most countries, was how do we make sure that the researchers who have expertise that is important are put in a position to actually act and to act fast. And I think that was already mentioned. And generally speaking, research funding is a finely tuned process of peer review where the best proposals are being identified by peers and then funded. And to match that with the pandemic, where we want answers ideally like yesterday, is a challenge that we all faced, the entire research funding community. And in Germany, we were lucky. We had a few, so we had funding set up where we were able to rapidly release funding to initiate these broad studies ranging from better understanding the virus, addressing ethical or social or legal concerns, but also testing first potential antivirals, and to get essentially the research community started. And I think we are still reaping the benefits of this of our ability to do this very quickly. So the pandemic started like in January, February, I think we met at the WHO to discuss research and research funding, and our first funding call came out early March, and I think we did benefit from that head start. And then nonetheless, it always feels like you're too slow. But we were also able to fund the vaccine development nationally, but also internationally. Here also we benefited greatly from experiences or conclusions from this Ebola epidemic in West Africa years ago that led to the establishment of this ZEPI organization, the Coalition of Epidemic Preparedness, and that allowed us globally to first of all get a head start on developing or supporting the development of COVID vaccines, but also there had already been funding for coronavirus vaccines prior to COVID-19. And of course that was, so they didn't start at zero. And when we later start about pandemic preparedness in the future, I guess the question is, knowing what we know now, how far would we want to go before the next pandemic strikes?
Professor Hunkale, what's your view on that? You are someone who coordinates research. You also connect the dots between various studies that have been done. How has the web of interconnections changed just through these past 1.5 years? And is it enough to actually be a base for future pandemics?
Well, it's certainly a good base, and it was a very wonderful experience on how people went into a collaborative mode, not only in the regions of society that you can see outside, where I think the support for each other was quite great, but also in science, where usually single achievements by single groups or single individuals often win high praise, but group efforts are more harder to materialize. And I think we saw here all of a sudden people went into collaborative mode and achieved things together, which was quite impressive to see.
I heard this week an executive of Pfizer actually retell the story of how the BioNTech vaccine wasn't just developed. Initially, it was developed as a vaccine against cancer, but this fast switch, lightning speed, as many people refer to it, who know a lot more about it than me, was only possible because there were personal connections into the United States, but also into Pfizer, which allowed this to actually go a fast track. So how much is the human element, and how much more of a structure do you hope for to be able to deliver lightning speed that is probably less reliant on personal connections in the past?
Well, I think, in fact, we should lay those networks, and those personal connections should be there. We were sort of lucky in a way, because these efforts of creating a cancer vaccine, which mean that you have to form an individual vaccine for each individual patient, made these companies like BioNTech and Moderna and similar develop programs that they can turn around a vaccine in a very, very fast way. In fact, I think the BioNTech data is that 63 days after they designed the vaccine, a first patient was started into a trial. So that's, compared to what we were used previously, where this would take years or decades, was just unbelievable, unbelievably fast. The question is, however, in a way we got lucky, because this wasn't set up for dealing with a pandemic. So we could use it for a pandemic, but it wasn't the plan, or not at least the primary plan, to have these infrastructures established for a pandemic. And we have then seen that there was some significant discussion on how to get the things manufactured, and get them manufactured in numbers that we can actually help, if you wish, a worldwide population. And so obviously we have learned some significant lessons there, and can perhaps also, as Frau von Messling pointed out, take that into the future in terms of international collaboration to extend that preparedness to a level that we're actually capable of reacting through the entire workflow.
Professor Zander, I would like to get into the nitty-gritty of your daily work. Now you are very much a public figure here in Germany and beyond. How much of your time are you actually still spending doing what you spent most of your time doing before the pandemic, which is the research, and which new interconnections would you hope for, or do you need to look ahead?
Well, I do still spend a considerable time, luckily, in the lab and with the study teams and so on. So that is the majority of my day, besides patient care. But obviously, with all these connections and collaborative work and collaborative networks, also comes a lot of work with communicating, coordinating such teams, as well as coordinating with funders and reporting and all of that. So I do have to say that, and it seems that many of those mechanisms are still being applied in a similar way as they would be in a non-pandemic situation. So if you're asking about the nitty-gritty details on the ground, so to say, I think that is something where maybe we can find modes in the future where we know this is an extraordinary situation, such as a real pandemic threat. We can use some of those tools, but maybe we can adjust some of the rules that would just reduce administrative work and some of the work that goes along with coordination, and free up even more time for faster discoveries and research time. That is not an easy task, obviously, because that requires a lot of legal work, but that is something I think most scientists always agree on. Obviously you want to spend all your time looking at data and interpreting data and coming up with new ideas and testing those. But I think in a pandemic situation, obviously anything that you can take away from all of this other burden would be a great help. This being said, I think especially Germany, other countries as well have done a great job in providing funding rapidly. But again, if we're asking about what can we improve, I think that would be one aspect that I would recommend.
I just want to remind everybody briefly that if you have a specific question, this is your chance. If you enter it in the chat, I will be able to put it to this very distinguished channel. And you were mentioning data. I just spoke with Ms. von Messling just before about how data is handled in Germany and how liberal Germans are with their data. Just to ask you, Professor Zander, what are the limitations of data management, both when it comes to digitization, but also in which data is accessible to you as a scientist in Germany as opposed to other scientific environments?
Well, I mean, we're familiar with the German system. We sort of grew up in this system, and we're used to having at least quite limited access to, let's say, public data and health data. I think that is also something that is a really big topic. It's not my specialty that we have to concentrate on, that we have to improve, but it was quite impressive speaking to some of the representatives of Israeli health authorities and as well as healthcare providers, and how fast they could see real-time data, analyze those data, and basically translate it into public health policies very quickly. And I think we can be quite grateful for their system, because there's so much we can learn from it. And I mean, just today we were discussing Israeli data again on booster campaigns and the effects. So that is definitely something we should strive to improve in our, in the German data debate. Obviously there is data protection, and that is highly valued in Germany, and that has a historic perspective, and I agree. But again, pandemics obviously have their own rules. My phone's going off. Sorry. But I think this is a debate we need to be having. The healthcare system and healthcare data can really, if we make them accessible both to caregivers as well as to scientists under certain predefined rules, I think can in the end save lives. And that is again a weighing of risks and benefits. And I think that is a very healthy discussion we need to be having. So bottom line is, our health data that we would love to have is not easily accessible to us in Germany. Luckily, we have other countries that are more liberal with that, and maybe we can get into discussions with these other systems and how to improve our German situation here.
Mrs. von Messling, I mean, clearly Germany and other countries are benefiting, particularly also from Israel, which became very much a global lab, particularly for the BioNTech vaccine. Now, you are the intersection of political action and scientific understanding. Germany will have a new government soon. What kind of plans are you putting on the table to think ahead and also match requirement, necessity with the democratic standards? Because I think one thing we can all agree on is that the pandemic itself is not much of a democrat at all, is it?
Absolutely no. That's true. I think when you look at the pandemic, I think it's a little bit like this movie Alien, right? So you have that thing on your ship, and it's either they win or we win. And we can't negotiate with the virus. And I think that makes it so different from other political situations where you have another party that you can negotiate with on the other side of the table. That's the usual interaction in a political sphere. And here this virus is a bit more binary. Either it does infect you, or if you're infected, and you meet someone, either there is a transmission, so it's 1 for the virus, or there's no transmission, then it's 0 for the virus. And this is difficult to deal with in a political process, if you think about it, where everything is about negotiating and identifying common interests. And so it's very hard for a political system to deal with such a pandemic. And I think what we are experiencing now, and looking back and trying to learn from what we've experienced so far, will certainly drive and structure how we will be prepared in the future. So I think specifically one of the things on the plus side is that this investment in research, and not just research that immediately translates into a product that we can sell, but basic research in a broad range of topics, that has paid off big time. Like Professor von Kalle said, this was cancer therapy. If you had asked before the pandemic, well, if we want to prepare for a pandemic, what should we do? Then we would have thought of the big vaccine manufacturers and thought, okay, they will provide the answer. And what we learned is that this pandemic, actually, in this pandemic, other actors took the lead. And it was this time it was a discovery from the cancer research field that gave us vaccines, and the next time around it will be maybe from some other area, and all of a sudden we were interested in aerosol distribution and how would such a virus move in the air, and we were all of a sudden talking to engineers and then to social scientists. If we think about how do we implement measures, how do we gain support in the population, that's not a question that a virologist will necessarily be able to answer, but there's people out there who that's their research topic. And I think one of the things we've learned is we need to, this investment that has happened over the last many years, that has paid off big time. And that is something that's totally worthwhile. I think the other recommendation is, especially in medical research, there's been for a long time more skepticism towards product development and in collaborating between academic and industrial partners than maybe in other areas. So I think computer science have no issue there. And we've now seen that this is also something that's absolutely worthwhile, like understanding the other party and working together and finding common ground and working out the nitty-gritty on how do we get something from a discovery all the way to a product, and what are the regulatory obstacles, what are the obstacles in the production area, all of that. That is now something that is being talked about, and that is something, if we keep talking about this and working that out, that is going to be a big part of pandemic preparedness. Because the truth is, if we go out there and say, oh, if we only invest enough and work hard enough, then this will never happen again, then we are bound to fail. Because then there will be other pandemics, and what we can do is we can prepare so that we can respond faster, that we can make sure more people are protected faster or are treated faster, that the impact is less severe. But all the pandemics we've prevented in the past, nobody notices, right? You only notice the one that gets through, and that'll be the same in the future. So we have to think about preparing and about response times and all these types of things, and not about, oh, this should never happen again, because I think you are very right in saying this was one of the better case scenarios.
Yes, Professor von Kalle, maybe you can pick up there, because actually that was kind of, that was a bit of a gloomy outlook. If you're saying this is an amuse-gueule from hell, the scientific landscape reacted in lightning speed, so did actually it did a lot of the intersections from politics to industry compared to previous vaccine development. So if this was a huge success, and we're still in a situation where we are, where Germany is currently facing a fourth wave, large parts of the world are not vaccinated yet. What else is out there?
Well,
you don't know. That's the problem. Yeah.
Yeah, some we do, some we don't. But I think the mistake that we can make is sort of have that warm, fuzzy feeling that we did quite well and that everything was easy and okay, and we pulled out of it all right, without critically rethinking what were the parts where we really did well intentionally, what were the parts where we did well because we happened to do well, and what were the parts where we actually did pretty miserably. Like, remember your first weeks and months of personal protective equipment. Everybody was getting out their sewing machines and making masks, and we didn't have our personal protective equipment in place. Data in the public health system. We don't have computer data to supply our Gesundheitsämter, our public health system, with information on who is sick, where, and when. We're lacking a lot of the access to what Leif Sander just mentioned in terms of the clinical data that we so desperately need. We can have a discussion also, and I think the research ministry, is doing an exceptional job rethinking on what we need in terms of the infectious diseases studies that we need to be doing in the future. So I think it's not gloomy. In a way, it's almost an exciting challenge that we can master still much better than we have done the past ones.
Well, but how much of it was awareness? Because we know that, I think it was Belgium that actually destroyed some protective equipment because they thought they didn't need it. And also it's not that there weren't any plans, it's just that nobody expected this to ever actually occur. There was actually pandemic planning in Germany, but just nobody took it seriously enough to actually buy the protective gear and the equipment. So now we're at a different level of awareness. How can you harness that for your work?
Well, the harnessing, we're all humans, so we're very impressed, but also, fortunately, we have the ability to forget and do what is important to us in the near to midterm future. So like we probably wouldn't be buying all these airbags and safety belts and equipment in our cars, but we lose the license to drive if we don't have them. So there's a system of checks and balances where we, when we're clear and right in our minds, we make a decision on what seems to be reasonable, and then we check and make sure it actually happens. And I think for those measures that we think are necessary for pandemic preparedness, we also need sort of an ownership principle. Somebody must be responsible for that the things actually happen, and you would sort of lose your license to operate as whatever, a hospital or an industrial site or even an individual if you don't take those precautions. I think it's going to be very important that we have an infrastructure that actually acts. We had the discussion earlier that the political process is so complicated. We often now focus on the stakeholders rather than the principal problem. And so some of more first principle thinking on going back to what actually needs to be done on the ground, and then asking the question, who do we need that? Who do we need for doing that? I think will be more important. We've gotten to a very politicized process where we're thinking, do the doctors like it? Do the scientists like it? Does the public like it? But we should go back to asking us the question, what actually needs to be happening?
Okay, well, scientifically speaking, Professor Sander, what needs to be happening right now at this moment in time in Germany?
Well, I think,
scientifically speaking,
I think science has actually delivered quite a lot. It has delivered the tools. We have the vaccines. We have some exciting treatments that are, soon going to be licensed. Just to mention monoclonal antibodies that can neutralize the virus if they're given early. There are some other antiviral drugs that are, I think today, one drug was licensed in the UK, and I expect it to be licensed soon. And then there's other drugs in development. So I think science has done a good job. There are other drugs that have been repurposed for treating severely ill COVID-19 patients that are already being used in the clinic. So I think we've learned a lot in 1 year. Science has delivered a lot of tools for us to be handling the pandemic in a good way. Obviously, there are other issues. It's not just science, it's politics, it's society, many challenges. And obviously with vaccine hesitancy, which has very, very deep roots, is a big obstacle to ending this pandemic in Germany. That is very, very obvious. And so I don't think, I do still think we need more science. We need more clinical development because this virus is going to stay with us. So having even better medicines to treat the disease once it resurfaces, and maybe refine the vaccines, stability of the vaccines, how to administer the vaccines, make them cheaper, make them broadly available. All of that is important for us right now. If you're asking more broadly what we need to do for preparing, I completely agree with Frau von Messling that investing in a very rich and diverse research environment was a good choice for Germany, not to focus on, if we had focused on some specific bug that I don't know, EHEC a few years ago in Germany, if we've had, prepared us just for this type of challenge, we'd be unprepared for this. And, I think, going very broad is a good strategy that we've had success with in Germany. And then, as Christoph von Kalle said, going back and taking a really hard look at the mechanisms at how we executed, some of the initiatives that we had to take very rapidly during the pandemic, such as providing funding, providing gear, enabling our hospitals and so on. I think some of these processes that were obviously born in the moment, they can be much more improved if you have more time to think about them and say, like Christoph von Kalle said, what actually needs to be done, thinking it from, what needs to be done on the ground, and how can we build the framework around that for this to happen even faster. And but obviously, this is something that we can utilize this time until, and that's inevitable, we'll have the next challenge.
Now, we heard from quite a few members from your team, actually. Do you currently have the funding that you need to do the research you need to do to prepare for the next pandemic?
So if you're asking a scientist if there's enough funding, you'll always get the same answer. But I would like to say that we have received generous funding from various partners, and this both from public funding and private funding, and I think that has been very, very productive. As I said, there's always room for improvement, and obviously, and I think that's healthy. A scientific, a lab, a group, a research group will always obviously have more ideas than funding to test those ideas, and I think that's a good way. If one day I run out of ideas, then we can stop basically. So I think we've done a good job in Germany in providing funding, but I still think basically when we think about translational research and clinical studies, many people look to the UK. I think they've done a tremendous job, and why not look into the best systems and what can we learn from them, and so I would still say a job well done, but still room for improvement.
And Ms. von Messing, how much of a moving target was this pandemic? Because initially there was, is there a cure? No. Is there a vaccine? Now there is a vaccine. Less than 70% of people are fully vaccinated in Germany, despite the wide availability that much of the world does not enjoy, that luxury. So did you then suddenly throw funding into psychological studies? It is a moving target because the challenge is different. And what do you know of what you will need for the next pandemic? Or do you not know yet?
Oh, so you are raising exactly the right question. So this is what we are trying to do. yeah, I know. So I think the question, what will we need? What will be the next layer of questions? That's what we think about every day, and sometimes we are spot on and sometimes not quite. That's kind of how this goes. I think very early on already that social and psychological aspect of the pandemic was on our minds, and we have a number of studies that address that. Now, the problem with the studies is that to do a good scientific study means you have to plan it properly, and you have to execute it, and you have to analyze it properly, and that takes more time than people have patience because they do want the answers. So
you said about a year. That's 2 waves of a pandemic.
That's 2 waves, exactly.
Yes.
Now, the thing is, first of all, it's still absolutely worth doing these studies because we can learn a lot for the next time around. And the other thing is that we can also learn what type of setup, and that a little bit builds on what you were saying, what setups are helpful to have these studies quickly up and running and have data quickly. And there is other countries who have interesting arrangements or interesting pre-setups that allow them to be very fast. And we are certainly looking at that and trying to translate that into our system. Then I think the big questions earlier this year, I remember at end of last year, we were starting to talk about long COVID and saying we need to look into this. This is an important topic. It also is a great opportunity to better understand that type of side effect that is also known from other infectious diseases. I think right now, a lot of the discussions about future pandemics is the question, how can we be faster? That came up earlier as well, because we will not know what type of challenge this is. We need to have structures that allow us to have vaccines quickly, to be faster on the drug development, to be faster on the answer, what type of protective behavior is effective. I still remember us all washing the hands and washing our groceries. And I think we quickly realized that the masks, where we initially were not sure if that was really making a difference, now I think that's been answered. This type of fact-finding and better understanding what is needed, that is something that we think about. How can we stimulate research in that area so that we are next time quicker in our response time, because it will always take time to develop a vaccine. But where did we lose time, and where could we be faster, and where can we essentially pre-load the system, have already things that we can then quickly implement. And I mean, that's a great side of our job.
Professor Zander, you both want to respond. Professor Zander.
I just wanted to sort of not answer, but add to that, in that there are so many unknowns, and this is why it's good from a scientific standpoint. We should be still investing very broadly in all the different disciplines, because we can't know if it's engineering, like you said, or some other discipline that we might need. But there are some things that we already know are going to be critical, because there's going to be an urgency. If there's a pandemic like this, it's going to be a high urgency to do and also to set up both research and development of drugs. There's going to be an urgency in setting up clinical trials that will characterize the disease. If it's a new disease, there's something that needs to be basically done immediately, and in the end, clinical testing and licensing and also manufacturing. And I think this is some things that we will already know. We don't know what to manufacture and which vaccine to produce, but we already know that this is probably something that needs to be done. And this, I think, can give us a head start if we start, learning about some of the processes that maybe we might still be able to improve.
Professor Kalle, did you change the infrastructure to get preloaded?
Yeah, I like this preloading term very much, because if we looked at some of the things that we did not have, so for example, we did not have the health data to collect to the public health system. We did not have a network of all the university hospitals to throw their data together. We got that now. There is no reason at all to not continue doing that in quote-unquote peace times where we don't have a pandemic, because if that machine continues to operate and not maybe researching something completely different, but the network is there, the funding structure is there, so that it can be sort of repurposed if we get into a next one. Remember the BSE pandemic, for example, bovine spongiform. A lot of people have forgotten, that was also.
I lived in Britain at the time, so it's hard to forget, yes.
Yeah. That also almost belongs into the same pattern. And then, for example, with the vaccines, we have a lot of unsolved problems in vaccines. Why don't we, make flu vaccines with the RNA system? And why don't we get contracts and research out there to deal with those bugs that we already know that bug us, because it will improve our preparedness to deal with the next one. So I think there's a lot of things that we can do also, if you wish, in the interval towards the next pandemic, which is hopefully 100 years away, but maybe not.
Okay, well, I'd just like to ask Professor Zander something that's just come in as a question. What's the role of therapeutics in a pandemic? Was that neglected in contrast to vaccines? Is there a lesson for the future?
I will answer this question in 1 second. I just want to add something that you, Christoph, just said, is that I think we should use some of that energy and some of these things that we've learned now from a very urgent pandemic everybody is aware of. We have so many other pandemics that have been with us for decades, and probably, if we move like we did, are going to stay with us for decades, and translate some of that energy and some of that innovation into those existing pandemics, such as the AIDS pandemic, the TB pandemic, malaria, what have you. There are many other neglected infectious diseases that would profit greatly from this innovation that has been sparked by COVID. So I fully agree with Christoph. So what's the role of therapeutics? I think early on there was a lot of focus on therapeutics, because all of a sudden you have these patients with this new type of disease on the ward, and a lot of different drugs were thrown at these patients to basically to see what sticks, and this is basically what people did out of desperation. Think of Italy, where people had to share ventilators and what have you. Whatever drug you can find that would alleviate some of those this misery would be great. So I think and what we can learn is to immediately start, like in Britain, the recovery trial, doing these kind of things in a very systematic fashion, to be able to learn from these experiences very quickly. And I think that's been successful. It took a few months, and we knew we'd have to give severely ill patients dexamethasone. This was great, and this came out of a trial, I think, that was set up over a weekend or so in Great Britain. So that is really something that I think the whole world has profited from. So if we can have something similar in place, that would be great. I still think that, like I said, therapeutics are going to be important. The vaccines are absolutely instrumental in sort of bringing us out of the acutely pandemic situation into a more new normal. But therapeutics are going to be important because I fear that in every winter season we're going to have COVID-19 waves, just as we have influenza waves or RSV waves, and so we need good therapeutics. So if we can improve in that arena, that'll just come down to less people being on the ICU and losing their lives due to this new virus. So I think we need that focus. We need to maintain that focus, but I think actually we have some good developments on the way. But let me finish by saying, I think in Germany particularly, we can maybe even do a better job at also participating in developing some of those treatments.
Professor von Kalle, just because Professor Sander sung the praises of the other positive effects from all that research that is being done, Dr. May earlier from Bristol Myers Squibb warned of the silent victims of this pandemic in terms of access to healthcare, but also in terms of research that is not being done. How big is the damage there?
Yeah, there is damage because obviously people don't undergo the treatment or even the preventive procedures that they should have, especially in the field of cancer. Cancer in itself, if you wish, is an ongoing pandemic of sorts. And so we really have to be careful. Of course, we had the discussion where we noticed that in Italy and other parts of the world, the hospitals were actually becoming vectors, and people who would go there would become very sick, and some of them would die. And so the decision in itself to say we restrict hospital activity until we figured out how this works was very important.
That's the here and now, but also in terms of science research that is not medical research that is not being done because all resources are on COVID or the next.
Yes, but I mean, we only have so many resources, and also, like, for example, the RNA vaccination in COVID now is a beautiful phase 1 trial, if you wish, on billions of people with regards to the cancer vaccines, right? So a lot of the things that had been learned now in the infectious diseases can vice versa can be repurposed in cancer. So I think we should just try to act smartly and see where can we use what we have learned to improve, where do we need to catch up, where do we need to get the patients into the hospital to get their preventive measures, to get back to a stage where we're diagnosing cancer early, and where sort of have we lost the lead. So we need to take a look at that very carefully.
Now, I was going to ask you as a final question, all of you, whether we are prepared for the next pandemic, because I like to try and answer a question, but I have a feeling that it's going to be yes and no from all of you. So I would like to start with Professor Sander and ask, what do we need most, or what do we need a lot less of to be better prepared for the next pandemic? To you all, starting with you, Professor Sander.
What we definitely need much less of is heated public discussions about very sane and scientific, data. I think, this is also something that has come along in the past few years. I think also are amplified by social media, which on the one hand is good because it provides information quickly, can disseminate information, but unfortunately it can also disseminate a lot of misinformation. And so I think if there's some way, this is something that we need to deal with as a society anyway, because that alone will help us through the next pandemic in a much better way if we can sort of calm down and focus on facts and sane decision making. Sorry for that, but that is something I would really like to say. The other thing is, basically you already said that it's yes and no for many areas. What do we need more of? I think it has been said already. We need this if you wish, preloaded system, and like I said, readiness also to execute clinical trials very quickly. That obviously under normal circumstances we follow very well established routes that we have in Germany, but in a pandemic situation, just as we've changed some of the legal framework for public health interventions, we should also change legal framework for clinical trials, which will allow us to go faster if the next pandemic or crisis hits. So I think, and that is primarily a political legal discussion that scientists cannot contribute that much to, can only say this is what we would like to have as a situation. So that is something I wish would be part of the political discussion in the next few years of the new government, and that would, I think, definitely enable us to respond quicker and better to the next threat.
Ms. von Messing.
I think that's actually pretty good what you said. I think what we need more of is common sense. And I think you can see this already now, that whenever you succeed in communicating in a way that people can kind of use that information and translate it into an activity for them, then this works well. We see it in other countries where this was maybe in parts more successful to essentially take your population with you, whatever you do. And I think our scientists and everybody has made a great effort to communicate. I think there we have to look at, I think there's room for improvement to help understand what should I do, what's going on, and what is my role in this as whatever where I'm at in society. I think a lot of our decision-making system is made for peacetime and is made to make sure there's no mistakes, all boxes are ticked, and I think we will do well at looking at this and figuring out where can we, in an emergency situation, have a process that does still maintain our expectations, and that comes back to what you said. What do we want to achieve? What's important to us? But that maybe does away with some of these extra layers of requirements that we have for good reasons in peacetime, but that in an emergency situation takes up a lot of time that we don't really have. So I think that there's potential, and I'm optimistic that this is one of the priorities that people will look at in the next month and years.
Professor von Kolle, probably being very specific, what do you never want to have to face again if you get news of the next pandemic striking?
That's hard for me. It's hard to answer because a lot of the things that I saw, I very much liked. I think what we need more is courage, in the sense that a vast majority of the population, of the adult population, has been vaccinated. A vast majority have voted for parties who stand on this side of the matter. A vast majority of people have interacted in really wonderful ways. So I think with that noise and static that we're hearing from some of the people who disagree, that's what I don't want to see, is that gets projected so very large. We still have to remember that the vast majority of the population has contributed to what is happening, likes what is happening, and is fully supportive of what is happening. And I think we should just always keep that in mind.
Okay, well, thank you very much. Christoph von Kalle, Leif Erik Sander, and Veronika von Messling, thank you very much for sharing your thoughts and your projections, although a lot of them seem to be rather gloomy, for the future pandemics that we still do not know which direction they will come from. And just before we have go to the World Health Organization, actually, and get their take on this, we would like to listen to more scientists who give us a view into their work. So a 4-minute clip on that, and then we'll be right back.
The COVID-19 pandemic has posed a high-level threat, leading to intense scientific activities around the world, including numerous regional, national, and international epidemiological surveys and registry studies. However, it is exactly this multiplicity of scientific efforts that threaten to create a dangerous segmentation of information, resulting in a delay or even preventing urgently needed scientific findings. Most of the data sets are not standardized, making it extremely difficult to compare or analyze COVID-19 data across studies, as well as using AI and machine learning algorithms. Data scientists spend most of their time working on data preparation and not on tasks like the actual development of machine learning algorithms. A lot of their time is spent collecting, cleaning, and reorganizing data, compared to a small percentage which is spent on machine learning algorithms. To make data more accessible to AI and machine learning and reduce data preparation, you need standardized and interoperable data. This will ensure that algorithms have a clear data structure and semantics to work with, ensuring the validity of results, and creating trust in digital technologies. To encourage coordinated action and assurance of semantic and syntactic interoperability and common language of the data collected, the German Corona Consensus Dataset, short GECKO, was created, giving scientists a standardized dataset for COVID-19 research as a universal working basis and language. GECKO is based on the PA COVID-19 study, the WHO-IZARIC protocol, and the data concepts of the LEOS register. However, the uniqueness is that it was developed by a multidisciplinary expert board containing approximately 83 data concepts and 280 response options from different domains like demographics, vital signs, and symptoms. Most importantly, making use of the international standards and terminologies like SNOMED-CT, HL7 FHIR, LOINC, ICD-10, GM, and ATC. The Pioneer dataset has provided researchers with a universal approach to understanding clinical data. GECKO has already created momentum that can be accessed online at any time. Used by projects within the COVID-19 research network of University Medicine, Netzwerk Universitätsmedizin, and Europe-wide within different projects. By not standing still and staying prepared for future pandemics, the team around the GECKO is currently working on further modules to accompany the dataset, making it even more interdisciplinary by harmonizing and streaming research.
So those were the scientists there from the Berlin Health Institute talking about how to make data more comparable. And making data comparable is also an issue Oliver Morgan has to deal with in his daily work. He is the director of the Health Emergency Information and Risk Assessment Department in the World Health Organization's Emergencies Program. Welcome, and we very much look forward to what you have to say about how prepared we are, not just for dealing with what we're facing right now, but those potential pandemics of the future.
Well, thank you very much indeed for having me. It's a real pleasure to be with you. For many years or even decades, the risk of a pandemic has been a major concern among the public health community. But it's not just been the public health practitioners who've been worried about pandemics. For example, in their 2019 Global Risk Report, the World Economic Forum considered that the risks to the global economy posed by pandemics are as large as that of climate change over the coming decades. Despite the prominence of pandemics in the assessments of global risks, I think we can all agree that the world is not sufficiently prepared for the COVID-19 pandemic. This is perhaps even more surprising given that we've been living and continue to live with pandemic risks all of the time. Currently, every month, WHO identifies 4,500 signals of public health events that we are concerned might have epidemic and pandemic potential. We conduct about 300 investigations worldwide each month to assess the risks of such events. Moreover, in recent years, there have been several large public health events that have posed serious pandemic risks, such as SARS in 2003, influenza A H1N1 in 2009, Ebola in West Africa between 2014 and 16, and Zika virus in 2016. In short, considering that we live with constant epidemic and pandemic risks, and that we have experienced such several major public health events of global importance in the last 2 decades, we must seriously evaluate how we can be better prepared for the next time, which will surely come. Like public health institutions across the world, WHO has faced its share of challenges during the COVID-19 pandemic. These challenges span many aspects of the pandemic response, including collecting, analyzing, and communicating information as quickly and as clearly as possible, managing huge quantities of rapidly emerging scientific information from around the world, and synthesizing that information to be used by clinicians, public health practitioners, and policymakers, understanding the effectiveness of public health control measures and advising member states around the world, and continually assessing public health risks, such as the emergence of SARS-CoV-2 variants. WHO has been very engaged in developing coordination mechanisms with the academic, private sector, and government partners for the equitable distribution of scientific technologies, such as diagnostics, therapeutics, and vaccines, known as the ACT Accelerator. The first step towards being prepared for the next pandemic must be bringing the current pandemic to an end. In the previous 24 hours alone, there have been 487,000 new cases of COVID-19 and 7,321 deaths due to COVID-19 reported to WHO. And this pandemic is certainly not over. To bring the pandemic under control, WHO has set a target of vaccinating 40% of the populations of every country by the end of this year. WHO also recommends continued use of public health and social measures to keep the disease incidence low. And while WHO continues to work hard with all member states to bring an end to the current COVID-19 pandemic, we are also working hard to strengthen the world's capacities to detect and respond to the next pandemic risk. During the last World Health Assembly in May this year, all member states spoke about the need to have stronger public health surveillance systems globally to detect new risks as fast as possible. Collectively, we need to be able to identify public health risks as quickly as possible and mitigate those risks wherever they occur and whatever the nature of those risks are. We need to have far greater capacity to conduct intra-epidemic and intra-pandemic monitoring to understand how our control measures are working and how pathogens are evolving. We also need better forecasts to anticipate where risks may occur and what the impacts may be. We need to improve our decision support tools so that leaders can take the best decisions based on sound analysis. And perhaps most challenging of all, we need a new global data ecosystem that enables insights from data to be shared much more freely and quickly, integrating crucial contextual data such as weather, travel, animal health, public sentiment, and many other aspects. To address these challenges, WHO has established a new hub for pandemic and epidemic intelligence based in Berlin. The focus of the WHO hub is to strengthen pandemic and epidemic intelligence through better data, better analytics, and better decisions. The WHO hub will accelerate the implementation of some existing initiatives, such as the epidemic intelligence from open sources and sentiment analysis for infodemic management. And it will also innovate in new and evolving areas, such as the analysis of large-scale genomic databases and the development of a semantic web of knowledge that links diverse data from multiple sources. I'm particularly grateful for the exceptionally strong support and collaboration from the federal government of Germany to establish the WHO hub in Berlin. Building our joint capacities to detect and understand future risks whenever and wherever they occur will require us to strengthen existing collaborations between all member states and build new collaborations with other partners worldwide, especially those who work across the human, animal, and environmental interface. I think it's fair to say that the scale of challenges for WHO has been unprecedented. All member states have simultaneously experienced a massive acute public health crisis. While we continue to learn important lessons for the future, we can also benefit from the many reviews already conducted about the global response to the pandemic, which themselves have resulted in more than 200 recommendations. It is clear from these reviews that the world does need a stronger WHO with sufficient capacity and mandate to identify and manage pandemic and epidemic risks wherever they occur. However, we must also work together to address major shortcomings more broadly around global health governance, financing, and systems and tools for pandemic response. The COVID-19 pandemic has pushed our healthcare systems to their limit and beyond, and we cannot be prepared for the future if we do not invest in primary healthcare as a foundation of universal health coverage. To be prepared for the next pandemic, we need to continue to work hard to end the current pandemic. We need investment for new capacities, such as the WHO hub in Berlin, and we need to strengthen our healthcare systems, as well as addressing shortcomings in global health governance. No country can end a pandemic alone, and no country can protect the health of its own people without working to protect the health of everybody. Thank you very much.
Oliver Morgan there from the World Health Organization's Health Emergencies Program. Thank you very much for putting this into a global perspective for us. And just as a reminder to take from what you just told us, 487,000 new cases within the last 24 hours alone. This pandemic is far from over. At the same time, you investigate some 300 potential new pandemics, what could emerge as being new pandemics every month. Thank you so much for giving us that insight. And that leaves me here in Berlin to just sum up what that key message is that we can take away from the many experts we've heard today. This pandemic is far from over. Data sharing, a new data ecosystem is required in order to allow for scientists to actually connect the dots for those pandemics of the future, both to find cures, but also to find those new vaccines that no doubt will be needed. We've seen as one of the challenges here today, not least public communication, the public debate, the psychological element of pandemics, which is something that we heard here today, will certainly be taken even more into account. And what proved to be the backbone for the research done during COVID-19 is the very broad approach of research in countries with a broad research environment like Germany, Europe, the United States, and the need to broaden that out also to poorer countries with ideas coming from everywhere around the globe, and a need to connect those scientific breakthroughs fast to those who can actually translate them into medicines, but also those vaccines of the future, and to upscale to a global level, something we're still struggling with as we speak today. So a lot of plans will be in the drawer, and all the experts here today are pretty much certain that nothing will go according to plan once a new pandemic of the future strikes, and still lessons learned, that interconnectivity, that fast-track communication, and that collaboration that crosses boundaries beyond the levels that we've known before. So that brings us to the end of this Future Medicine Roundtable 2021, with big thanks to all the partners that were able to make this happen here today, and the inputs, not least from all those scientists who let us look behind the scenes, and your questions coming in. Thank you very much, and we look very much forward to talking to you at the Future Medicine Roundtable next year in 2022, which in scientific terms still feels like a million light years away in what could happen in terms of the pandemics and beyond. Thank you so much for tuning in.